Hey, before we get into lecture today, just got a few announcements. Some things that I've been forgetting to mention in lecture itself. Things that I've been talking about. I bring them up in Q&A when I finally remember, but I forgot to highlight them in lecture. You've seen this in the Piazza posts. Nick set up the Piazza groups for each team, and it was in that post for you. But the team websites are hosted at CSEsoftware.com. If you want to check out your team site or any other team site, this is where they're going to be hosted. My intent is to have each app hosted here. At your team name is the subdomain .cscsoftware.com. And then at the end of the semester, your phase 3 projects should all be hosted here, hosted at these. And this is why Docker is so important for us, is I can go into this server and run Docker and have each one of your apps up and running in a short amount of time. So I map each port to a specific port for your team. And then each team has their app running on a different local port, even though you're all working on 8000. So when I spin up your Docker container, I can map a local port to port 8000, and then have my proxy server be able to serve based on subdomain to a specific port. So anything from team 1, for example, is going to be forwarded to port 8801, and then that's how I have my proxy server set up. I run this on port 8001 or 8801, map that to 8000, and then have my proxy server map team1.ccsoftware.com to port 8801 locally. So I just want to show that. If you want to check out the other teams, there are 27 teams. Most of them are up and running. Some of them I've talked with the team. We have just some compatibility issues and the like, but most of the teams are up there. It's only phase 1, so of course you know what you're about to get looking at them now. But as we move through the semester, as we get to phase 3, we should have full usable apps. Is the ideal situation. Is the goal there, obviously. And there's something, I feel like I'm blanking on something that I wanted to talk about before. Something that I remembered right at the end of Q&A Wednesday. If anybody remembers and can give me a reminder. I might also be thinking of CSE 116 with that one. But for those of you who stick around for Q&A, if you can give me a reminder. Grading. Oh, yes. Thank you, Struggling Through Life. With the save. Yeah, grading of homework. I'm not logged on to Piazza on this machine, only my laptop, so I can't pull it up. But the grading of homework. So I wanted to do this over spring break, but of course the whole world transformed over spring break. I finally got to it last week, over the weekend. I forget when I did it. Fairly recently. And I posted on Piazza. For those of you who didn't see Piazza, if you're watching this on YouTube or something, and just haven't checked Piazza for whatever reason, check Piazza seriously though. You should at least be checking the pinned posts. I would like to say daily, but I'm not that optimistic. The homework grading, how your numeric 0 to 3 grades on the homeworks translate over to percentage grades. So all the grading to determine your letter grade is based on percentages out of 100 and averages, and then your lookup chart for letter grades is based on those percentages. And I left this undefined for the first half plus a few weeks of the semester, mostly as my way of curving the class. I'm not going to have a traditional curve, but kind of just seeing how the class is doing overall. That's how I decided to map those 0 through 3 grades onto percentage grades. So it's not just a 1-to-1 mapping. Like a 1 out of 3 is not a 33%. That would be way harsh, especially when 70% is the cutoff for an F. That would be way too much. So the mapping is a 3 is 100. That's expected, of course. A 2 is an 80%. A 1 is a 60%, and then a 0 is a 0%. If you didn't even try it, you deserve a 0 for that. And then that's how you can take all your homework grades and figure out where you stand in the class in terms of percentage grades. So all of you can compute your current percentage grade based on all the information that you have available to you. So if you're curious how all these homework numbers are going to translate into your final score, you have that information now. And the next big announcement, I just refreshed the server. Just if you want to refresh and see that I'm not just making this up. I don't know why I would. I don't know why I say things sometimes, but I was looking over the deadlines. There has been quite a bit of demand about, or not demand, but requests about the Project Phase 2 deadline. So that Project Phase 2 deadline, I am pushing back by a full week. So this Sunday, those of you who are currently 16 viewers right now, who are currently skipping lecture to work on your project, which I assume, that's just what happens, is you can forward the word to them or whatever. But that project, you're going to get an extra week to do that. There's still some confusion about Docker Compose. I'm going to go over that today. I did do slides. There was a request for slides in the Q&A on Wednesday. I'm going to go over Docker Compose again, make sure that content is out there and solidified a little bit more, and you have more time to digest that. The problem with this is, what I always say is, well, if I move something back, there's only so much time in the semester, and I'm going to run into deadlines. So I was looking at all the deadlines, all the assignments that are due. I was looking at it all last night, trying to make a decision, trying to figure out how I can make more room in the schedule. And I just decided, let's lighten things up a bit. Cancel homework 9, put homework 8 due where homework 9 was, and then leave the rest of the schedule as is. So for homework 9, to make sure this doesn't affect your grades, some of you might have needed homework 9 to raise your grades up. Everybody is going to get full credit for homework 9. So everybody is going to have 100 in the books for homework 9. So you don't have to use a drop, but it also doesn't increase the weights of all the other homeworks. I think that's the most fair way to do it, is just give everybody full credit for that instead of restructuring the whole grading structure. And using that week, that front-end 2, we can still talk about front-end stuff, but if I can do more project help, get you even more ready for Phase 2, if you have Phase 2 questions during those lectures, we can talk about Phase 2 related stuff. And just show off apps. I'll show off the files, the image sharing site again today. If we want to go through that and talk about the details of that multiple times and go in nice depth about the architecture of an app, but how all the pieces fit together, the front end, the back end, the database, all that, how everything fits together, and just kind of digest the whole semester so far, what we've talked about the first 10 weeks. How do all these things gel together? We're at the point where we have all the features for an app. We've seen all the core, like, this is what you need to get a real product out there and working for you on the internet. Everything beyond this is just kind of extra, just bonus stuff. Anything you learn about web apps, at least in my opinion, anything beyond that is extra. Like, okay, how do we scale this to 1 million users? How do we add streaming features? How do we have authentication where you can log in with Google? Things like that are kind of like extra topics. But if you don't have authentication at all, you don't really have a web app. In my opinion, it's there's a lot of things that you just can't do. Will we still cover homework 9 content in lecture? This is one thing I was kind of sad about if you're really looking forward to the front end stuff. I'll still cover some of that. But here's my little secret, is not too secret now, is there was no, like, I didn't have the content ready for that week. I wrote that on the schedule at the beginning of the semester, thinking, well, I have plenty of time to really formulate what I want to do for that week. and I just never really got there. To be honest, I personally find the front end fairly boring, so it was getting hard for me to really find something interesting that I really wanted to talk about that week. I was going to talk about data binding, where you have a JavaScript variable tied to a value in your front end. I could talk about Bootstrap and just making things a little prettier. There's just not something. I can't find a front end topic that has that both really improves your website, your web app, and is also has some technical details to dive into that we can really sink our teeth into. Nothing's really difficult on the front end. Even cracking open the frameworks, there's just not much going on in there, to be honest. Nothing like implementing a whole new protocol. Everything on the front end is just made up because it's only specific to inside the browser for that one site. So I don't know. There's just not much interesting there. We can still talk about front end stuff. I can pull in some frameworks. We can talk about them. And if you have requests, as always, it shouldn't just be my opinion of what's interesting or not. If there's something interesting that you want to know, if you just want to watch me go through the tutorial for Angular, I don't know what you want to see. But if you have something you want to see related to front end, something that would fall under the front end 2 category, let me know. Is 70 still enough? Yeah, so 70 is still enough. So if you get all 1s on everything, that would still be enough. You get a 60 average. But as long as you have some 2s and 3s in there, it should bring your average up above a 70 for a pass. If half of all of your homework objectives are 1, and assuming you have no zeros after drops, you still pass. You're still above a 70. But yeah, I'm not going to curve the cutoffs. The cutoffs are what they are. And then I set the mapping of 0 to 3 to percentage grades as kind of my way of curving and making that 70 sting a little less. So homework 9 was going to be building features that are common in front-end frameworks, building those from scratch and doing a little bit of from-scratch coding on the front end. But I don't know. I just didn't have... I could have racked my brain this weekend and came up with something great and it would have been fun and everything. But, to be honest, I'm feeling burnout too. Like, this is... usually at this part of the semester, we're all feeling it. But with this whole change, it's more so than normal. Homework 10 did not build on Homework 9. Homework 9 was a one-off. That's why it was so easy to scrap it. Yeah, there's Q&A every day, coffee and burgers. All right, so it looks like I have other questions answered in chat. Let's... Is there anything... So everything that I did have planned, it'll still go in this week. I just didn't have a full week of material planned yet already, so we're not really strictly missing out on anything. Mern stack. So you have the M and the N, assuming you've done some Node. And we can talk about React. Oh, and Express. You should have the M, the E, and the N. All those are within your reach. It's just the R that you're talking about, I assume. I'll release Homework 10 as soon as I have it ready. I don't hold back on you at all. When I release something, that's when I finally finalized everything. I don't hold back at all. And React, this is 15. If you want to hear my spiel on this, you want me to get on my soapbox a little bit, you can ask during Q&A. But like the front end frameworks, just I don't think it's really college level content, especially not 300 level. I think the tutorials are pretty straightforward, and the expectation is that you can go through those tutorials and understand how to use React or Angular. There's just nothing. There's no real like technical thing that you're going to come across when working with those that we haven't prepared you for in 115, 116, 250. Like, there's nothing that's going to completely come out of left field and hit you over the head and be like, I am completely unprepared for this. It's just going through the tutorial. If I'm wrong and there is something that you feel you're not prepared for, we can talk about that specifically. But if I prepared lecture content on React, Angular, or Bootstrap even, I feel like I'd just be holding your hand through the tutorial. So if there's something in one of those tutorials that you're struggling with, let me know and I can cover that piece. But just walking you through the tutorial and creating slides that, like, the tutorials are so good, I don't feel like I can do any better with the tutorial. And there's really there's no like concept I can pull out of that front end and talk about that concept in lecture. There are a few that I could kind of pretend are concepts, but really it's just programming tricks and stuff that make front end developers' lives easier. And if I'm being really honest and giving my hot take, I think they're built so people can build front ends without knowing how to code. And that's not you. That you're not that audience. You could just have raw JavaScript and build those things, except to have the pretty GUI features, this isn't an art class, except to have the pretty GUI features. There's nothing those libraries are doing for you that you can't code. All right, let's get into lecture content. I spent quite a while in that. But on the plus side, we have all next week too, so if I don't cover today's stuff, the time crunch, that time pressure is eased off a little bit. Oh, it's fine to. That was one case where it was fine to derail lecture a little bit. That was I wanted to. Was sensing that the class is pretty stressed out. I wanted to take that time to unwind, just enjoy having deadlines pushed back for a little bit and relax. 20 minutes of that is perfectly acceptable. If nobody said anything, I'd just be awkwardly sitting there talking about how stressed out everybody is. Nobody wants that. Talking about React instead was much better. All right, but let's get into today's content. Oh, there was one more thing. If tic-tac-toe.info is up and running, we do have authentication, registration on here. So if you want to play with that, this is what we're going to be talking about today and probably Monday. Is how to set this up. I'll give you the overview of the theory behind it. I've already mentioned most of the stuff we'll talk about today, but I want to talk about it specifically and highlight it. And then I do have the slides on Docker Compose and walking through those that were requested in during Q&A on Wednesday, which, to be honest, I should have had last Friday. I realized that Docker Compose is a little more confusing than I expected it to be, that I should have some proper slides on it. So let's talk about authentication, where we've talked about the kind of theory behind this. What's SHA-256? Why do we hash? What's entropy? And things like that. And how attackers are going to attack these passwords, what we need to prevent against. We talked about all that. Now let's talk about how this actually fits into a web app. So once we have all this background, how do we apply it to a web app to get authentication for our users, to actually deliver a feature to our users instead of just telling our users, hey, we salt your hashes. What does that give them? What feature does that give them? And of course, it gives them user accounts and the ability to authenticate and navigate the site as themselves. So this takes 2 steps. So just a recap, registration and authentication. We're all very used to this as users, but now we want to look at it on the other side. Of course, and what we saw is when somebody registers, they're going to send us at a bare minimum a username and password. We're going to validate that password strength on the server side. So if we want to do any validation, we have to do it on the server side, because anything we put on the front end, they can just rip all of that JavaScript out of the front end and send us a weak password anyway. Anyone who's validating passwords on the front end better also be doing it on the back end. So you can have those front end validations, and this is one of those things that the Frontend Frameworks would give you. You can have those things so as a user's typing, every time they hit a character on their keyboard, it says your password's weak or strong or medium. If you want those things, those features to deliver to the user, you can do that on the front end, or have a bulleted list that checks off as soon as you type a character. Okay, you have a number now. Type a special character. Okay, you have a special character now. If you want those usability and user experience features, there is value in validating on the front end. But if you're doing that, you also have to validate on the back end. So we're on our server because they can just delete all that JavaScript code and submit anything anyway, or just access your API directly. So we need to validate the password on the server side and then respond to the user if it's not strong enough. If it is strong enough, according to whatever criteria we decide, we're going to salt and hash that password and store that salted hash. We're going to prevent the rainbow table attacks. We're going to prevent those scattershot attacks where an attacker can attack every hash at the same time. And we're, of course, not storing in plain text. That would be... Anyone storing in plain text these days needs to get out of this industry, to be honest. But a salted hash is the standard these days. A salted hash of that password. And we use libraries like bcrypt. Bcrypt is pretty standard out there. And leverage all of the work that they've done. If you're building your own stuff, I know we do that a lot in this class, but if you're building your own stuff, there are almost certainly going to be weaknesses in the system. If you have really sensitive information that you're storing, salted hashes, pull in bcrypt and use bcrypt to store those passwords. Authentication, once a user has an account already registered, when they want to log in, they're also at a minimum going to provide their username and password, and usually it is just username and password at this point. We're going to go to the database, look up that username, find their stored salted hash, take the password that they provided, which will be in plain text, remember, this plain text password, salt and hash that, so the database is going to store not just the hash, but the salt, that plain text salt. We're going to append that plain text salt to the end of this password that they provided, hash that, and if both the salted hashes are identical, bit for bit identical, we're going to authenticate that user. We're going to say you are who you claim you are, because it looks like you had the right password that you used during registration. If they're not bit for bit identical, we're going to say we can't verify that you are who you say you are. We're going to say try again. Bad username password combination. There's the big problem with this that I've been mentioning really throughout the whole class, since we started talking about cookies, is that you don't want somebody to have to log in every single time they take an action on your site. So you don't want that username and password being sent every single time somebody does anything that they need access to. So every time they click a link, or every time Ajax needs to get an Ajax call needs to get more information that should be specific to that user, you don't want them typing in their username and password every time. Nobody's going to use that site. Nobody's going to visit your app if that's what they have to do. Even if they just have to re-authenticate every time they visit your site for the first time for that session, for that day or whatever, even that's going to be pretty bad. We want people to be able to restart their computers and everything and still be able to visit our sites without having to re-authenticate. That's the feature that we want. So when we authenticate, instead of just checking the username and password, salting, hashing, and looking up the database and then saying whether they're authenticated or not, after that process is over and we say you're authenticated, you are who you are, we're going to generate a random token with a lot of entropy. 2 to the 80 is what I specify in the homework. That's our rule of thumb in security in this in the crypto community that says that's secure enough-ish, like 80 bits of security. After that, we pretty much consider that secure. Less than that, we consider it not secure. Just as a rule of thumb, it's not a hard and fast rule, like you actually are secure after this. It's just kind of a number that the community has agreed upon. But if you have at least 2 to the 80 guesses that somebody has to make, or 80 bits of entropy, which that's what this is, 80 bits of entropy, we're going to say that's good enough that nobody can guess this token. Then we're going to associate that token with the user. So every time we see that token, we should be thinking that token is associated with this username that authenticated with that username and password We salted and hashed that password, looked up our database. We did all that good stuff, verified that this user is who they are, who they say they are, gave them that token and assigned them that token. So we're going to store in some database somewhere that token and that username associated with each other in some way, however you want to store that information. In the app that we'll see, I associate that by having a document in a MongoDB collection that's in the form of a JSON object with token username. I just have their token and username in that collection. So any way you can associate that token with that user. For your homework, you can just put that in a CSV file, have one column be username, one column be token. That'd be perfectly acceptable. Now this, I have a duplicate slide. It's the same exact slide. It happens sometimes. So once we generate that cookie, we're associating it with the user on our end. And we want to also associate that token with the user on their end. So 10 bytes. Yeah, so if you have 10 bytes of completely random information, and then base 64 encode that to convert it to a string, that would be a good token. Or if you have a string, so say you have a string with just lowercase characters, for example, the length of that, 26 raised to whatever length you choose, and then the log base 2 of that has to be greater than 80. So however you get there. But yeah, if you want to work at the bit and byte level, it would be 10 bytes of purely random zeros and ones, and then convert that to an ASCII string. Base 64 is pretty much the solution for that. Token and cookie, yes, there are differences. Actually, that's this slide right here. So once we generate that token, we're going to set that token as a cookie for that user. So once they log in, that HTTP request that contains their username and password, our response to that request is going to contain a set cookie header. That set cookie header is going to have that token associated with it. So the cookie, we've worked with cookies earlier in the semester. You've set a cookie, you read a cookie to see if a user was visiting a page for the first time or not. So cookies are its own thing, separate from the token. We can use cookies for lots of different things. They're used for tracking us, to be able to shove ads in our face that we might click on. But we also use cookies. Cookies have a lot of different uses. We also use cookies to set these authentication tokens or these session tokens. So this is one more application of a cookie. So we're going to set that as a cookie, and if you want that extra bit of security, you can sign these cookies with your private crypto key. Sign those, and then whenever you get that cookie back, verify the signature to make sure that you were the one who set that cookie. It's not strictly required. I'm not requiring that in your homework assignment. Since you control the entropy, and you can have enough entropy to have these be practically infeasible to guess, this would just be an extra step for mostly, I'm hesitant to say it, but kind of for the paranoid. But if I'm deploying a sensitive app, if I'm a bank, if I'm developing banking software, for example, I will definitely be at least this paranoid. I'm going to sign all those tokens. I want every layer of security I can get. For phase 3, do we have a handle? Do we have to handle user logged in on multiple browser computers with multiple token per user? I guess I'll say no, because that probably won't show up in my specs. Yeah, I'll say no, you don't have to, but it's not entirely difficult to build. Right? Yeah, HTTP only, kind of. I actually don't even talk about that in these slides. I talked about it briefly during the cookie slides, but it depends what you mean by security, whether that adds it or not. So HTTP only and secure and I guess same origin as well. Those are all directives for the browser. And if somebody's using a browser that, actually, yeah, I guess it does add more security. No, if I'm thinking about it, we can talk about that during Q&A. I can talk about that a bit, but it's up to the browser to enforce those, and the user has control over the browser. So if we're trying to use those directives to prevent an attacker from doing something, there's no security there. So they're going to get the source for Firefox, they're going to rip all that code out of there, and they're not going to have to follow the HTTP only directive. But we can set those to help a naive, innocent user navigating the internet from their browser betraying them. So it will help if our users are subject to a JavaScript injection attack, that HTTP only can help those users. And the same origin can definitely help those users. Yeah, the same origin protects against the cross-site scripting. And I guess HTTP only, right? We can talk about it later, but the same origin is going to protect against the cross-site script vulnerabilities. The HTTP only, I have to think about that. I don't know if that really prevents anything, if I'm thinking about it. It just makes the attackers go through one more step. Yeah, we can talk about it. I can think about it more. We can have a conversation. So now that it's a cookie, every time this user does anything on our site, or rather every time they make another HTTP request to our site, we're going to get that token. That token's going to be part of that request. We're going to read the cookie's header. We're going to get that token. We're going to look up that token in our database to find that username. And now we know, since this user is in possession of this token that we gave to this specific user, that we're going to be confident that this is in fact that user. So nothing's ever 100%. I'm careful to not say that this is that user with 100% accuracy, but we do verify that this person is in possession of the token that we gave to this user who did authenticate at some point in the past. We do have that much information. That cookie might have been stolen somewhere along the way. It's very possible. But we do have that much confidence that this is the token that we gave that user during authentication. Since there's enough entropy that nobody should have been able to guess that. Even if they're... and we have enough entropy where even if we have 1 billion people logged in and all they're trying to do is guess the token for one of those users, just trying tokens and then asking and trying, we have enough entropy that even that is infeasible. And at that point, they would have to do billions and trillions of guesses. At that point, hopefully there's something in our system that's going to detect that much abuse. So we have one big concern here. These tokens have to be stored securely. These are as sensitive as passwords. If somebody gets one of these tokens, they set that cookie. They have their dev version of a browser. They compiled from source and ripped out the HTTP only code. They set that cookie with that token, and now, according to your server, they are that user. No need to even get the password involved. They just take the session cookie, that authenticated session cookie, and our server is going to treat that person like the person that they're imitating. Our server isn't going to know the difference because that's how our apps are set up to work. It's how the internet works. It's how every site you visit knows. I would assume you're not visiting any sites that ask for your password every single time you do anything. They're working with cookies, and if those cookies are stolen and you have a database full of them that could be stolen, that's a problem. So we're going to do the same thing that we did with passwords. Similar thing, I should say. We're only going to store hashes of those tokens. And then whenever we get a request, we're going to read that cookie. We're going to get that token. We're going to hash it and then look up that hash in the database. So if somebody takes that database, they can't recover the tokens themselves. They only get the hashes. Now they're at the point where they have to crack a hash, except now we have 80 bits or more of entropy. They're not cracking those hashes. These aren't weak passwords. These are purely random, very long strings. They're not cracking they're not cracking these tokens, unless for some reason you chose to use weak tokens, which don't do that. Just don't do that. And 80 bits is a minimum. If you're concerned, I don't know, go up to 150 bits of entropy. It's not we're not too concerned about storage here. I'll go all the way to 200 bits. Make sure it's impossible to crack these tokens. You can salt them, but you really don't need to here. Since we have so much entropy, the salt doesn't really matter at this point. Salts are helpful when people use weak passwords. The reasons for using a salt just don't apply here. The rainbow tables aren't going to work here with tokens. Tokens, you shouldn't have any token collisions, two tokens that are the same, so that finding the same hashes, that's not really a factor. And attacking every token at once, say you have a billion, like 2 to the billion is 2 to the 30, thousand, million, billion, 2 to the 30. If you have a billion tokens, a billion users all logged in at the same time, and you have a billion of these tokens in a database, that's 2 to the 30 tokens. If you have 2 to the 80 entropy, you still have 2 to the 50 guesses that somebody has to make, or a quadrillion guesses that somebody has to make to be able to crack one token if they're attacking all of them at once. So possible, yeah, and especially if that's the case, maybe go up to 110 bits of entropy. So even if you have a billion tokens, you still have 2 to the 80 guesses that somebody has to make. Since we control the entropy here and we can have arbitrary entropy, we just don't need to take those other precautions. But if you're paranoid, or if you want that extra bit of security, go for the salt. Nobody's gonna I'm blanking on the words to use here, but nobody's gonna make fun of you for using a salt. Nobody's gonna be like, you're using a salt for tokens, why are you gonna do that? If they do, point me in their direction so I can make fun of them. There's no reason to salt, but if you are, so what? It's fine. There's nothing to lose by salting, is what I'm saying. You're not losing anything, and you are potentially gaining a tiny bit. It should be really hard for people to steal the cookies on your browser. Actually, depending on a few things. If they have physical access to your computer, they have access to all your cookies. Anybody you're sharing a computer with, make sure you're logging out of everything, or else they have all your cookies. An attacker just out there on the internet, it's really hard to get those cookies if the sites that you're visiting, that you're logged into, are doing what they're supposed to do with the same origin policies with cookies, and encrypting everything using HTTPS and all that good stuff. If they have all their security policies in line and up to date, it's really hard to steal a cookie. I had a salt to the salt. Yeah, you can salt the salt, store a hash of the salt, a salted hash of the salt. Yeah, it doesn't hurt anything. At some point, you're going to take a tiny performance hit, but the crypto stuff, it's all hashing and everything. It's so fast anyway. Unless you have like millions, billions of requests per second, you're not going to notice the performance hit. 900 rounds of salt. Yeah, you're going to take a performance hit at 900 rounds of salting. If you click a link that runs JS code, can they take your cookies? Yeah, so this is where the same origin policy comes in. Again, we can talk about it during the Q&A. I want to try to at least get through the Docker Compose slides and get through these slides. Then we can talk about that at length. And talk about how all that works and all that. All right, so we got that one. Went through that. I accidentally hit my mouse wheel. So whenever we get a request, we're going to take that token, hash it, look it up in the database. If it's in that database, we have the username for this person. And once we have that username, we're going to treat this request as though it were made by that user. And again, I'm being careful to say we're 100% confident. I'm not saying we're 100% confident that it is that user, but our app is going to treat this request as though it were made by that user, and we're reasonably assured that that is actually this user. Unless this user is, sending their cookies over email to all their friends or something. There could be reasons why it wouldn't be that user, but we're going to treat that request as though it were made by that user. If the token is invalid, for some reason we have a broken token or something, or the cookie just isn't set at all, we're going to redirect to our login page. They're trying to visit something that that requires authentication. If they're not authenticated, we're going to say, whoa, you got to go visit our login page first. If you don't have an account, you can register. We're going to send them there. What you see on the internet, if you log into something, grab a URL for an authenticated page, a page you had to be authenticated to visit, open up a private browser, paste that link, you're going to be redirected to the login page, as you would expect. You expect that feature. And then secure everything that requires authentication. So the front end can never be trusted. Somebody can visit. Actually, what I just said, that was somewhat unintentional. I'll play it off like it was, right? Anyway, if somebody is just pasting a URL like that, they might not be navigating your app in the way that you expect, in the way that you drew it up. They might be jumping directly to some authenticated page that requires authentication. So you want to make sure everything that requires a login, every single request needs authentication, including like API calls. If you have some AJAX set up for somebody to retrieve information, you better be checking that authentication cookie, that token, for every API call, every single thing that they visit your site for that needs authentication. Make sure that you're checking for that token every single time. And if you don't find that token, do not send that sensitive information. No matter how they made that request. Somebody can put together a custom post request without visiting anything else on your site. They might send an upload request for content for your site. You need to authenticate every single piece of functionality that requires that you expect somebody to be logged in to access. Everything has to be authenticated. Always remember this. You can never, ever, ever trust your front end, because an attacker can delete your entire website, all of your front end, and interact with your endpoints, your paths, and your API, and your APIs in any way that they choose. And if they see a vulnerability in there, they see a way to be able to access your server in a way that's going to break things, you have to assume that they're going to find it. You can't give them that opportunity. All right, let's talk about Docker Compose. I might go through this quickly right now, and then again on Monday, and we can go through the whole image sharing app and go through that a lot slower on Monday. But I at least do want to, in 6 minutes, get through all of these slides and talk about this Docker Compose file. So I showed this last Friday. I had a couple Docker Compose files that I showed. And I just kind of flashed them around and said, here's a Docker Compose file. And I thought that was enough. But in retrospect, I realized that this does need some more attention. And it was called for in the Q&A. So let's go through some slides on this thing. So this is a Docker Compose file, which we're going to use to start multiple Docker containers that can communicate with each other. So we have this problem of wanting a database set up and also our app, but we want to use Docker to get all the benefits of Docker to be able to move this app around multiple platforms, to have their development environment the same as production environment. It's supposed to be, at least. I had an issue with one team where it just didn't want to play nice with my server. I still want to find out what's going on with that. But anyway, we have multiple containers that we want to run. So we have our app that needs a database. We could set up a database manually, run a database, and then have it connect to that server. But now we're losing some of the benefits of Docker in that our app is nice and portable. Now every platform, every environment that we want to test or deploy or develop on needs to have a database up and running. And we have to all communicate, make sure that we have the same version of the database, make sure we have no version incompatibilities. The database is going to run differently on different OSs. We have all kinds of issues. So we would like to use Docker for the database to have the database, get the database up and running, and then have our app communicate. So now we have this issue. Do we have 2 Docker files? Like, how do we build that? What if we have 10 different services that we need to run? We have a lot of communication between them and everything. Do we spin up all those Docker files separately? And, a lot of questions like that. Docker Compose is going to come to the rescue and let us build one app with multiple services running on different ports that can communicate via TCP. That's what Docker Compose is doing for us. And for our purposes, having a database running and our app running and communicating with each other. So let's walk through this file. First, we need to specify the version for Docker Compose's file format, and the versions will relate to different compatible versions of Docker Compose itself. I'm just arbitrarily using 3.3. It's not the latest. I think the latest is 3.8 for what it's worth. But you have to have some version. You have to specify the version at some point. Next, we're going to list our services. So this is each piece of the app that needs to be running for our web app to be able to be functional. So each service we're going to list separately, and they're each going to run in a separate Docker container. So this Docker Compose file here is going to create 2 Docker containers, one for my database and one for my app. Each service gets a name. These are names that we choose. I can name these anything that I want. I stuck with pretty traditional naming, Mongo for my database and app for my app. Pretty straightforward naming. But we can name these anything we want. And these names are very important. The names themselves are not important. Choose whatever you want. But being consistent and remembering what you name these is important, because these are going to be used as the host names for the containers. And this is probably the one thing I wish I highlighted more last Friday, because this can cause some issues. That these are going to be used to be able to communicate between the containers. So my Mongo service, I'm not doing anything custom here. I just need Mongo, a Mongo image, something running MongoDB. This is the same thing saying use this image. This is the same thing as having a one-line Docker file that says from Mongo version number. But I don't need any Docker file for this. This was a question I got a few times. For my Mongo database, using it, running it like this, I don't have a Docker file for Mongo. I don't have a Docker file for the database. This is doing the same thing. Instead of putting this in a Docker file that just says from Mongo, you can specify the image name here instead of doing base image from using the from keyword. I can just specify the image here. And then this Docker Compose file, when I run Docker Compose, it's going to say, oh, Mongo, I'm going to pull this image just like it would with a Docker file that said from Mongo. And then I don't have anything custom, so nothing else happens. So Mongo is just going to run off of this raw image, just the image as is. That's what's going to run, and it's going to be named Mongo for my container. No Docker file for that. For the app, I do have a Docker file. For your purposes, you have the Docker file that you have from phase 1. You use that same Docker file and then specify the build. This is how Docker Compose is going to know that you're expecting that you have a Docker file for this. So Mongo, we said image, so it knows, oh, I'm downloading an image. I'm downloading an image from the internet. App, we're going to use build. That's saying, oh, this is something that has a Docker file. And then we specify where that Docker file is and where your app should be built from. And here I'm just going to use the current directory, whatever directory this Docker Compose file lives in. I'm going to use that same directory. This is the same as that trailing dot when you build a Docker image, when you do docker build -t image name and then that dot at the end. And if you're wondering what's that dot for, that's specifying the directory where this image should be built from. So when you say copy these files into my Docker container, that's specifying which directory the file should be copied from. And dot is how we specify the current directory, whatever directory you're currently in. So that trailing dot was specifying where to build the image from. we have to specify the same information in Docker Compose, because we're never saying Docker build this image. We're doing that through Docker Compose. So Docker Compose needs to know the directory for each service that we're going to build. We're only building one here, and we're doing it from the current directory. So it's the same thing as that trailing dot from building the container. Next, we set all our environment variables that we need. For those of you using MySQL, this will be pretty important. In your MySQL, instead of just pulling the image, you'll also want to set environment variables for your database, for your password, for your username. If you're not using the root user, you're going to need environment variables for each of those things, both in your database and in your app, so you can authenticate with your user. Mongo by default doesn't require a password and also doesn't allow remote connections, so we'll be okay for Mongo. For our purposes, for this example, this is where I had that workaround to be able to wait for the database to be completely ready before starting the app. I'm going to set this wait hosts environment variable to wait for the Mongo service on port 27017. And then in my Docker file, I downloaded this wait command. I made it executable and then executed wait before I'm running my app. So I'm waiting. That wait command is going to read the wait hosts environment variable and then wait for anything specified here. So this command is going to wait for this port to be open, or to be accepting connections on this container. And once it is, then my app is going to run. So a neat little workaround that this user UFO Scout built for us, made it available. So we're going to take advantage of that. And then exposing the ports that we need. I'm going to map the local port 8080 to 8000 for this example. And this is the same as when we use -- publish, or just -p if you want to like the shorthand, and then publishing with that port. We're getting that same functionality that we had when we used just raw Docker, but now we can specify the same information with Docker Compose in a Docker Compose file. So this is the same. This is like saying build -t name dot and then run publish 8080 to 8000. And then we'll still specify detach in the command line when we run Docker Compose. And then this file is used to both build and run both images and containers. Okay, we're a little bit over time, but I do want to get this one out there. These names are very important, and I glossed over this a bit last time, mostly because I was pulling my hair out trying to debug something. By the way, I never found the bug. As strange as that sounds, sometimes it goes that way. I never found the bug. I still don't know what was happening, but it works now. Like, it just started working. I didn't change anything. I think what was happening is that sometimes when I was testing it, it was working, but I just didn't notice it because I was pretty flustered at the time trying to get lecture on track. Because I didn't make any significant changes, and I undid any changes I did make to get back to where I was, and I don't know, it just worked. I don't know what was going on. Anyway, these names are how these containers are going to refer to each other. So usually we would do localhost if we wanted to connect to something, especially our database, our Mongo or MySQL database. We'll connect to it with localhost, and if we don't specify any parameters, if you just have, for this Python example, Mongo client and then no arguments, it'll default to localhost. So instead of connecting to localhost, we're going to use the host name as the name of that service that we specified in the Docker Compose file. So if I connect to the host name Mongo from inside a Docker container that was built with the same Docker Compose file, so inside this app that I'm building, inside the Docker file, whatever web server that's running, I'm going to use the host name Mongo, and that's going to refer to this container that's running from this Mongo image. So once I specify that, I can have my containers communicate with each other. And then Docker Compose is going to handle the DNS for that. It's going to resolve this domain name to this container and be able to connect to that container. And we don't have to expose any ports here because we're not accessing this container from the outside. On last Friday, you saw that I had some ports being exposed and ports being mapped to localhost, which you can still do if you want to connect to that container from outside, which I was doing during some of my testing. I wanted to run my database container and then test my app without having to run Docker Compose every time, building the image and everything. I wanted to run my app outside of Docker, but you still use Docker for this image. So I was exposing some ports and stuff for that. But you don't have to once you have everything set up to run purely in Docker Compose. Then you do this Mongo as a little bit of a sidetrack, a little bit of a tangent. But you don't have to expose any ports for those.